Hi everyone, my name is Eric Hare. I'm on the Omni Analytics team, and I wanted to give you a walkthrough of our newest case study, which we're calling a statistical dive into the unlock protocol. We're pretty excited about this one because although the analysis itself is pretty accessible, pretty straightforward, the routines we use, which basically begins from scraping directly from the blockchain transaction data on Etherscan, the routines we use are really general and not only make a great case study for pulling data, analyzing data, visualizing data from the blockchain, but it can really go beyond just the unlock protocol. So we hope you enjoy this. Let's go ahead and get started, and I'll walk you through what we did. So just a quick introduction on the unlock protocol. If you're not familiar with it, it's effectively an attempt to bring content monetization to the Web3 ecosystem with just like a few lines of code. You can essentially have a paywall or provide premium content, but it goes far beyond a traditional paywall, which is usually centralized track. This is decentralized open source, unlike traditional methods. So it's a really cool thing. Its adoption has been, as you'll see, quite significantly going up in the last few years. Okay, so what did we do? This is just a high level. This case study doesn't cover the details of the data scraping. We have some others where we talk more about that. This is more the downstream analysis, given that we already have the data, but I just wanted to give you a quick overview. We essentially scraped the data from the following contract address and essentially looked at the accounts that had interacted with this contract, and that gives us an idea for the usage as far as how widespread the usage of the unlock protocol is. For the individual accounts that interacted with that contract, we basically browsed to their page to scrape all the addresses they've interacted with, and basically included those if it was a contract. So you can see this example, like top bidder BID token was one of the contracts interacted with, that would be included. And so ultimately you can think of the data, people who interacted with the unlock contract and have interacted with which other contracts. So that's how we sort of assess the growth of the unlock protocol. Ultimately, the data kind of looks like this. We in this slide, we actually didn't show all the columns. There's also some columns for the address itself that just takes up a lot of space. So we selected some of the relevant ones, like the block number and block time, and then the contract tag, name, and token tracker. So this is just a quick example. You see that top bidder one that we were just visualizing on Etherscan. You can see it right here at the top of the data. So that's how the data looks. And fortunately, it's in a pretty clean format already to begin doing some analysis. It's not the richest data set, so like the different types of things we can do are maybe a bit more constrained than they could be in other contexts, but because it's so clean, we can pretty easily use some common routines in, for example, ggplot2 and dplyr to begin processing this data. Okay, so an initial thing you might want to do, we always like to begin any analysis by doing something like looking at the range of time that the data covers, because remember, we scraped this at a specific point in time, and it turns out we did that on May 27th. And so if we look at the minimum block time and the maximum block time, you can see the range of this data effectively goes from the end of 2015, December 2015, to May 2022. And that gives us a good solid 6.5 years of data to work with. Obviously, if we re-execute the scraping code, we will have even more data, and this analysis will be continually updated as we go along through time. Okay, and then, we might want to look at some quick statistics just to give us a feel for it. So total number of transactions aggregated over all time, we see 140,406. That's effectively the number of rows in the resulting data set. There are 287 unique wallets and then 10,209 unique contracts that we see. So that's kind of what we're working with here. Okay, so now let's go kind of outside just looking at aggregates. And, we thought it might be interesting, how is the number of transactions per month changed as a function of time? And so what we're doing here is a pretty standard date manipulation routine that we often do when we're aggregating time series data. What we're doing is we're basically taking those block time, the timestamp fields, we're basically sort of rounding it or converting it to month. So we're aggregating by month, counting up how many transactions we have, and then also computing a cumulative count. Doing so allows us to visualize both the daily counts of transactions as well as the cumulative amount on the same chart. So let's take a look at how that appears. You can see something pretty interesting. So first, you can see the plot does in fact begin December 2015. Transaction volume associated with this contract is quite low for that period of time, all the way really through late 2017 during the first big bull run. And then we see noticeable increases such that by 2020, the number of cumulative transactions was pushing 40,000. And then during the 2020-2021 timeframe, it really accelerated. And now you can see as of May, it looks like about 140,000 cumulative transactions. There's an anomalous, interesting little spike you can see in December 2021, which was actually the single most active month of the entire time frame, which was kind of interesting because putting aside that particular month, it almost looks like from the 2020 time period, like September to now, there was a steady downward trend, except for that big spike that we saw in the month of December 2021. Okay, now let's look at the top contract tags. So what we're doing here is we're doing basically a count so that we can make a descending bar chart. And in R, one of the things we're really doing here is we're creating a factor, an ordered character vector essentially with factor labels so that we can order the bars in descending order. Otherwise, this is a pretty standard routine where, again, we're just counting up the number of contract tags we see in the data. When we do it, we see here are the top 30. The number one on the list, Uniswap v2 Router 2, is by far the most common with over 12,000. And then Center, USD Coin, and DAI stablecoin round out the top three. Beyond about the top 15 or so, there starts to be a lot of very similar ones as far as the number of counts that they have, and you can see a smattering of them there. Okay, now the cool thing about this is for looking at things like the top contract name, we really can do almost the exact same block of code. What we're doing this time is we're just subbing in the contract name field from the data, but otherwise you'll notice that if I bounce between these blocks of code, they're nearly identical. In fact, if we wanted to formalize this a little bit, we might consider functionalizing this routine so that we can pass in a variable instead of replicating a code block that ultimately is very similar. But for the sake of just seeing how the code would be written in an ad hoc manner, this will do us just fine. So if we run that code, again, we get the top 30 contract names. That Uniswap v2 appears at the top once again. And then we see rounding out the top three, Inbetweeners and Fiat Token Proxy. DAI is also up there as number 4, and then kind of starts to trail off beyond that. Okay, and finally, let's look at the top token trackers from the data. Again, this is another argument to potentially functionalize this, as this is a pretty similar block of code. But generally, since we only have 3 plots we're making, it's not a huge deal. If we were going to be producing, say, 10 or 20 or maybe an arbitrary number, then it would really start to benefit us to do that. So we run similar blocks of code here, and what do we get? We see Inbetweeners actually rises to the top as far as token trackers goes, and then our friends USDC and DAI round out the top 3 when we look at that. CryptoKitties comes in at number 6, it looks like. So we hope you enjoyed this kind of brief little look into the Unlock protocol. and the data that we found on transactions associated with it. This was a really kind of quick look based on the data that we had available. There's a lot more I'm sure that we could do. If anyone's watching this and something came to mind, either an inspiration for the unlock protocol specifically and something we could analyze, or perhaps another contract or another protocol out there where an analysis like this might be interesting to look at, please contact us. Let us know. We're always on the lookout for more things we could do. And please also be paying attention because we will have plenty more case studies coming down the pipeline. And we hope you enjoyed this one, and we hope you continue to enjoy what we produce for you into the future. Thank you.